computer. Okay, believe the recording has started. All right. All right, well, let's get started. Okay. All right, very good, Gentry. Nice job helping your grandma. Yeah. Well, I hope you guys will have a good weekend, but let's take care of some math stuff, right? So today we are not going to have any type of math, um, such as solving equations, math related, but it's more of a concept about different type of numbers, right? Now, for example, like if I talk about myself, I can identify myself in terms of like different identities, right? For example, I can say I'm an Asian, I'm a Japanese, I can describe myself with a gender, right? Because I belong in sort of a group, right? Subset of uh, whatever racial identity to gender to or the occupation. I am a teacher, right? Or you are a student. You belong in like a sports club. I play volleyball. I'm in a volleyball team, soccer team, uh, baseball team. I think we've got some baseball players, right? Yeah. Now, same thing happens in numbers too. In number world, uh, there are some group of numbers that belong in certain identity. It has a certain identities. Now the lists are already there, but can you give me some examples of certain type of group of numbers that you can identify with? Any examples? Yeah, very good, Aiden. Those are even numbers, right? Isn't that a certain type of number? When I say even number, immediately you have some ideas, right? 2, 4, 6, 8, 10, right? And odd number. Okay, very good. Rational numbers, odd number, very good. How about positive number, negative number, right? So you've already know different bunch of different type of number, right? There are uh, again, there are lots and lots of different numbers. Prime numbers. Have you heard that before? Yeah. Yeah. Uh, Now, so I want you to know at least there are very typical um, classification of numbers. Okay. And I would like you to know those because it will come up over and over in different classes. Let's say if you go to college and universities, your professors might use the word integers, rational numbers. You need to know what those are. Okay. Now, the first one. So I would like you to write this. Let's do this. Let's write these down. Can we do that? I will give you maybe 3 minutes and then I will talk about it. Okay, as you copy this down, I want you to just think about and maybe generate some questions to ask me. But let me give you 3 minutes. Okay. Well, Emmanuel, good to see you. We are just copying down this whiteboard right now. So please take out your notes and start copying down. Would you indicate in the chat if you are done copying this down? All right, thank you. Very good. Well, if you're not quite done, please keep copying this down. But let me start explaining the first group of numbers that I want you to be able to identify is what's called natural number. Natural numbers are all what you might call counting numbers, right? You probably learned it in elementary school as counting numbers. Those are finger numbers: 1, 2, 3, 4, 5, right? No decimals, no negative numbers, okay? And I don't even know why they have the distinction between natural and a whole number. The next one, a whole number. What do you see the difference between natural and a whole number? Yeah, there isn't very much of a difference, except whole number is just like a natural number, essentially. Okay, it's pretty much identical, except whole number includes 0. Some textbook don't even talk about natural and a whole number, right? Because they are pretty much the same. But anyway, so you've got natural number and a whole number. Okay. Again, those are all positive finger number: 1, 2, 3, no decimals. It's all whole number. Okay. And the next one group is called integers. Now, what are integers? Do you see that? Integers are also whole number. It's 1, 2, 3, 4, 5. No decimals. Decimals are not integers. Okay, it's all whole number, except this time integers will include all the negative side as well and positive side. That means that natural numbers are also considered as integers. Are you guys okay on that? Is a natural number integers? Yes. Okay. Are whole number also integers? Yes. So integers are more like a bigger group. So again, it's kind of like this. I will show this to you later here in a diagram, but some of the numbers group are within the bigger group. For example, let's say I am, let's say if you are, let's say, South students, you belong as, well, if you came from, let's say, South, you are South students, right? But within the South, there are some smaller group, right? And so there are groups within the group. Okay. And natural number and whole numbers are inside of integer bubbles, so to speak. Okay. Next one is rational number. Now, rational number is the biggest, bigger group. Okay. Integer, whole number, natural number is inside of rational number. Well, we'll talk about that, right? But let's just talk about rational number. Now, what is a rational number? Rational numbers are essentially the numbers that can be written as fraction. Okay? But there are some two special cases, okay, where let's say you've got like a repeating decimals, 0.66666. Do you know what 0.66666 dot 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 is? You could actually rewrite it as a fraction. It's a 2/3. In other words, what I'm getting at is if you have a repeating number, decimals, you can always rewrite it in the form of fraction. In other words, repeating decimal is also a rational number because a rational number is a fraction. Am I making any sense to you guys? The other case is terminating decimal. Now, what does the word terminating means? Terminate. What does that mean? Terminate means it stops, isn't it? Terminate. I mean, it's got a lot of different contexts in English, but terminate, one of the meaning is terminate means to, it stops, it finishes, right? In other words, if there is a decimal that stops, it doesn't go on forever, but if it stops, then you can write it as a fraction. For example, 0.156, and it stops. And you can rewrite that as 156/1000. And if you can write it in fraction, it means that it's a rational number. So next week, I'm going to ask you this. I'm going to ask you this until you get sick of it. I will ask you, hey, what is a rational number? I'm going to say three things. Okay. Rational numbers are fraction for most, okay? And then there are two special cases. So fraction, repeating decimal, and terminating decimal. I want to hear those three things. Can you remember that right now? So just repeat, just speak to your computer monitor. What is a rational number? Three things. Say it out loud, guys. Fraction, repeating decimal, and terminating decimal. Did you say that? It sounds silly, just speaking to the computer monitor. Again, rational number is fraction, repeating decimal, terminating decimal. Okay, I'm going to ask you this next week, okay? Because they are all fraction, okay? Now, just going a little bit off the tangent, ancient Egyptians thought everything, all the numbers are rational numbers. Everything could be written as a fraction. That's what they believed, right? And that's kind of understandable. Why? Because there are lots and lots of fractions. Now, let me ask you guys that. Is a natural number rational number? What would you say? Is natural, let's say 4. Is a 4 also rational number? The answer is yes. Can you write 4 as a fraction? Anything that you can write as a fraction, the answer is that it's a rational number. Can't you write, how do you write 4 in fraction? Well, 4/1, 8/2, right? So you can write 4 as in fraction form. So natural numbers are rational numbers. Now, and the last group is called irrational number. Now, what is irrational? Irrationals are the numbers that cannot be written as a fraction. Very good, Francisco. Well said. So irrational numbers are anything that is not rational. It cannot be written as a fraction. It does not repeat. It does not terminate. So in other words, it's the decimal that goes on and on forever without repeating pattern. Can you think of such number? The number that goes on and on forever. It doesn't terminate. It doesn't repeat. And one good example, Gentry, a nice job, is a pi, right? 3.141592. It does not have any repeating pattern. It doesn't stop. It goes on and on forever. Does anybody know? Like, I know a teacher who memorized 100 digits of a pi. Yeah. All I know is 3.1415. That's about it. 1414159. Are there any other irrational? The answer is yes. Whole bunch of square roots. Those are also irrational. Square root of 2. Square root of 3. Okay. Now, how about square root of 4? Is a square root of 4 irrational? Square root of 4 is not irrational because square root of 4 is actually 2, isn't it? And 2 is a whole number, 2 is an integer, and 2 is a rational number, right? So, but all the other square root of 5, square root of 6, square root of 7, square root of 8. Now, square root of 9 is 3, so skip that. The square root of 10, square root of 11. All the square root numbers except the perfect square, those are all irrational. Yeah. So to show that what we just talked about, you can, here is the sort of a diagram representation of what we've just talked about. Okay. There are what's called all that we've talked about. Natural, whole number, integers. Those are all what's called real numbers. Okay. In a real number system, you can basically split it into two parts. One is rational number, and the other one is irrational number. Okay. They don't mix well. Okay, they are exclusively separate. Okay, you cannot be both rational and irrational at the same time. If it's irrational, it cannot be then rational. Okay, vice versa. Within rational number, you've got integers, okay? And then inside that, we've got whole number. And then within that, we've got natural number. So I would like you to write this diagram and keep it in your notes. So I'll give you a minute to do that, okay? Am I making any sense to you guys so far? So please keep writing this, okay? So maybe some of you are wondering, well, so what, right? So what kind of questions, maybe test questions? What am I gonna be what am I going to ask you guys? Okay, so here are some examples. Okay, we're just going to classify. Oh, also, I've forgot to mention each number group has its own symbol or letters. Some of them are pretty obvious, but some of them are not. For example, natural numbers. Natural numbers are, the symbol is big capital N. Okay, that's a natural number. And the whole number is W for obvious reason, whole number. Okay. But the integers are, it's a Z. And I did look up why it's a Z on the internet, actually, for the first time in this year, but I've forgotten already why it's Z. But anyway, I think it was the word from German, German word for integers or something, and it starts with a Z. I think that's what it was. But anyway, the integers is actually Z, okay? And lots of professors, teachers, they will just use the letter big Z, okay? And then the rational number is, it's actually not R, but it's a Q. So it is confusing, isn't it? Okay. And then irrational number is Q and little dash. You call it Q prime. That's how math people read it. It's a Q prime or a Q with a dash. German word Zahlen, which means numbers. All right, thank you. How about rational? Why is it Q? Does anybody want to Google that? Why is a rational number Q? Type that in. Anyway, so I will be also using those letters too. So I would like you to remember that. Okay. Natural number, pretty obvious. Whole number, W. Integers are Z. Rational numbers are Q. Okay. And then irrational numbers are Q prime. Prime in math are called, is the symbol for not, basically. It's not rational. So therefore it's irrational. Okay. All right, let's do one example. And then we're going to do the assignment in class. Remember that? Okay. So, for example, 2/5. What is that? How would you classify 2/5? Yeah, quotient. Oh, yeah, quotient. So that's why it's Q. Very good. We've got smart people here, which is good. Okay. You all are smart people. Okay. 2/5. Now, what is that? Where would you put it? If you were to put 2/5 in that diagram, where would you put it? It's a rational number. It's a fraction, isn't it? So 2/5 will basically go right there. Now, can it go inside integers, whole number, or natural numbers? No, you can't, okay, because they're no whole number. 2/5 is not, it's a 0.4, isn't it? It's not whole number, it's not natural, it's not integers. How about square root of 5? Where would you put it? So 2 over 5 is a rational number. Let's do that. And 2 over 5, square root of 5 is, it's irrational number. So let's write it down. Q prime. Okay. Is everybody okay so far? How about 3.172 stops? How would you classify that? 3.172 is, how would you describe it in words? It is terminating decimal, isn't it? Were you thinking about that word? It stops, it terminates. And terminating decimal is a rational number. So it is, again, we will give Q as a symbol. Next one, how about square root of, Kimberly? Very good. How about the next one, square root of negative square root of 9? What would that be? Now, just because you see a square root, it doesn't mean that it's going to be irrational automatically. But square root of 9, as you know, it's a 3, isn't it? So it is actually -3, same thing. So if you can simplify a number, you will simplify first, and then you're going to determine. Now, what is -3? -3 is a integer, isn't it? So that's a z. But also, -3 is inside the rational numbers box. Because you can write -3 in fraction form, can you not? -3 over 1, isn't that a fraction? So it is also rational number. So some numbers do have a multiple identities, okay? So negative square root of 9 is considered as integers and rational numbers. Last number, 8 over 2. How would you classify that? Again, anytime if you can simplify, you are going to simplify first. What is the 8 over 2? Isn't that 4? Thank you, Haley. That's a 4. Now, what is a 4? 4 is 4 a natural number? Yes. Okay. Is a 4 whole number? Yes. Is a 4 integer? Yes. Is a 4 rational number? Can you write 4 as a fraction form? Yes. 4 over 1. So it is rational number. So 4 has lots of identities. It's a natural number, it's a whole number, it's an integer, and it's a rational number. Okay. So that's what I'm going to ask you guys. Okay. And let's do the assignment. I think we should be able to finish the assignment in about 15 minutes or so. Let's get it done. Does anybody need more time to copy this down? So who was that came in late? Can't remember. I'm sorry, I forgotten your name already. For those who came in late, maybe you can just take a picture of this. You should write this down and also watch the video. after I post it, of course, but I will be posting this copy of this Zoom recording uh, by the end of the day. So please watch that. Okay, can we move on? Let's do the assignment. Okay, so in your notes, so here's the assignment. Now it's already posted in Canvas. If you want to print out, you're more than welcome to do that. You don't need it, okay? You don't need to copy, print out. We can just do this in your notes, okay? But before we do that, I just got it from somewhere on internet. So, but let's write it down. Homework, it's 1.1. So will you write this down? Let's identify this assignment as homework 1.1. We're just going to do the same thing as we just did a minute ago as an example. And we're just going to classify all these numbers. And we're just going to answer some of the true false questions. Yeah, let's do that. All right. Are you guys ready? Let's, how do we do this? Do you guys want to just copy this diagram and let's place each number into this diagram? Okay. So first question, -6. Where would you put -6 in this diagram, in this map? -6 is -6 is, what would you say? Where would you put it? Now, can you put -6 in a whole number? Now, you notice that there is no natural number, right? So, because natural number and whole numbers are basically the same thing. So, and that's why, so this, whoever created this worksheet, they did not distinguish natural number from whole number. So this is an integer, isn't it? -6 is an integer, right? It cannot be a whole number because whole numbers are all positive numbers. But this one obviously is -6. So it is integer. But then once you place it in integer, do you notice that it's also inside the whole rational number circle too, right? And it is also, well, yeah, real number. Next one. 2.73. Where would you put it? How would you identify that? .73. How would you describe it? What comes to your mind? Are you thinking about terminating decimal, right? And that means it's a rational number. 2.73 is a rational number. Okay. How about 3/7? Are you guys with me? Yeah, you guys doing all right? How about 3/7? Clearly, you cannot reduce the fraction, first of all. Okay. So it's a 3/7. It's a fraction, isn't it? And what is a fraction? Fraction is a rational number, right? Rational numbers are fraction, terminating, repeating, right? So if it's so 3/7 is a rational number. Next one. So you do this one. Why would you place square root of 2? What do you think? Square root of 2, whole bunch of square root numbers are irrational. So square root of 2. But then you see square root of 9. Now, square root of 9 is not irrational, even though it's a square root, because you can simplify. What is the square root of 9? Square root of 9 is 3, isn't it? Now, what is a 3? So where would you put 3? 3 is irrational, yes, but 3 is integer, yes, and 3 is a whole number, okay? So you need to place inside that whole number circle. That will put automatically inside integer. That will put also inside rational number, right? So 3 is a whole number, also integer, and also rational number. How about negative 100? Where would you put that? Definitely negative 100 is, what do you guys think? Everybody think about it, okay? Do you have the answer? Where would you put negative 100? You should be putting inside integers. Yeah, whole numbers are all positive numbers. So you don't want to classify negative 100 as a whole number. Okay, whole numbers are all positive. Okay, so it needs to be integer. How about 0? 0 is a whole number. Yeah. And how about pi? We've talked about that. Pi is irrational. Yeah. So we need to put that over here. So are you getting the hang of this? Very good. With a correct symbol too. Very good, Aiden. How about 1? Where would you put 1? Again, 1 is whole number. Again, yeah, once you put number in a whole number, that means that it's also integer. It's also in rational number circle, right? About negative 1/2. Again, that's a fraction, right? It's a fraction that you can't reduce any further. And so negative 1/2 will be, if it's a fraction, it better be rational. Yeah, very good. How about negative 3.8? Negative 3.8 is stops. It's a decimal. It's a decimal number, first of all, but it stops. It terminates. So what's terminating decimal? Again, it is rational number. So you need to be putting into the rational number circle. You can't put it in integer because it's not a whole number. Integers and whole numbers are all whole number. Okay? No decimals. But this one right here. Do you guys know the bar notation? Do you see this 5.42 and do you see the bar right there? Do you guys remember what that means? It means it repeats. It means that it is same thing as 5.424242 and then dot dot dot. Okay. Yeah. So what is a repeating decimal? Repeating decimals are, again, remember three things. Rational numbers can be described in three things. One is fraction. Second one is repeating decimal. And the third one is terminating decimal. I'm going to ask you this next week. Tell me three things about rational number. That's what I will say. Tell me three things. Rational number. Fraction, repeating, terminating. Okay. So it is obviously repeating. So it is rational number again, 5.42 repeat. The last number, 8.293017. Now you can argue that maybe that is the repeating pattern, right? But from what we gather, we will classify this as it's a non-repeating. It doesn't terminate. So therefore, it is irrational number. 8.293017 dot 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 dot. It means that it goes on and on forever. So it does not terminate. It does not have a repeating pattern. So it has to be irrational. Does that make sense? Yeah? Let's keep going. Let's just end right here. Let's not do the second page. Did anybody do a second page already? We'll talk about that as maybe a warm-up question next time. But let's answer those questions here. True or false? Okay, you've already done the second page. Great job, Yale. I'm sorry, I should have decided that way before. But let's answer the true or false question. First one. All whole numbers are integers. Is that true? What do you guys say? T or F, true or false? Yeah, would you agree with that? Very good. That's correct. It's a true. I mean, look at it. Are all whole numbers inside do whole numbers belong in integer circles? And it does, doesn't it? Doesn't whole number circle inside integer circle? Yeah. That means all whole numbers are integers. That's true. Some rational numbers are also integers. that true? What do you guys think? Some rationals are also integers. I think that's true, isn't it? Some integers like -6. Oh, some rational. So like -6, that's rational number, right? And that's also integers. So I think I would say that's true. Okay. How about number two? Oh, I did number three. How about number two right here? All integers are whole number. That's clearly false. Do you see that why though? All integers. Are all integers also whole number? No. Okay, that's a false. Because look at it. -6. Is -6 whole number? No, it isn't. Okay. So every integers are not whole numbers. But the other way around, all the whole numbers are integers, right? But not the other way around. So that's false. How about number four? Some whole numbers are irrational. Can some whole number be irrational? No. The whole number belong in rational number group. Okay? Whole numbers are rational. Rational numbers cannot become irrational number at the same time. It's impossible. Okay? It's either rational or irrational. You cannot be both. Your foot cannot be in both rational and irrational at the same time. So some whole numbers, it cannot be irrational. So that's false. All right. I think this is a good place. I think we've done enough of math today. Okay. All whole numbers are rational. Correct. Yeah. Very good. Good question. That any other questions, guys? Okay, so this is the end of. Let's stop here. I think we've done enough of math today. So I would like you to now take a picture of this, and then I want you to submit in Canvas. Okay. If have you guys all done that? I know I've asked you this before yesterday. If you do not know how to upload this assignment in Canvas, now if you go to modules, you will see the assignment 1.1, and that's where you're going to turn in. Okay, so will you take a look at it? So I'm going to dismiss you now. You guys will have a great weekend. But if you have any problem uploading your assignment into that Canvas, I will be sticking around. So please come back, or you can just keep your Zoom link still alive and try to upload it. Okay. And then if you have a problem, just stick around and let me know. Otherwise, have a great weekend, and I will see you guys on Tuesday. Okay. Monday is going to be kind of like a office hour where you can come in and get some help. Okay. So have a great weekend, guys. No, that's okay. True or false, that will do. Yeah, I think nice job, guys. Does anybody have any questions about uploading on Canvas?
So by uploading, are we able to do so with just a camera? Because I wrote everything on paper.
Yeah, so you can take a picture of that, right? Do you have
Mm-hmm.
a cell phone with you?
Yeah.
Yeah, and then um, so actually you can download Canvas app on your phone. So there are a couple of different ways. Have you done this before, like uploading assignment on Canvas?
I believe I have with the old math class when
Yeah.
COVID struck.
Okay, so one way to do is you can download actually Canvas app on your phone, and you can find Salem Kaiser School District, go through that process, and
Mhm.
then you can upload a little easier that way, right? The other way, and then you can just upload to the assignment 1.1. The other way is you take a picture, maybe send it to your email address, and then on your, I don't know if you're using Chromebook or your computer, and then
Personal.
yeah, and then you can retrieve the picture on your computer that way from your email address, and then upload it to a Canvas, something that's a little bit uh, more
Right.
process, but just try that and see how it works. If you have a problem, just let me know next week, okay? And then it's not a problem. We can try to figure out a way.
All right. Thank
Okay,
you.
take care, Francisco. So let's stop the recording.